All right, let's talk at the open media room, guys. I'm going to be talking about open source video mixing with real-time control, and also, most specifically, syncing multiple videos. I'm going to start with the project that this was done in, which is MistServer. It stores media in a certain way. There is a shared memory page in RAM that has stream metadata. Now for each track, for the audio track, the video track, potentially multiple tracks, there is another page in shared memory that stores information about the track. And it has references to more pages, even more in shared memory, that have roughly a minute of media data each. And what we do is that we write media as it comes into one of these pages. At some point it fills up. And then the older pages get deleted, and we keep like a small stack of them going, so to speak. This works great for media because usually, you want to be able to go back a little bit, stuff like that. And this lets you keep stuff in memory without needing to continuously rewrite stuff. But it doesn't work so well for raw video. So for raw tracks, we do something else. If you have a raw video track, we don't do all those extra pages. We instead allocate a large ring buffer of raw pixel frames directly in the video metadata page in shared memory. And then we overwrite those in a loop. This lets you do raw tracks without needing to continuously create files in shared memory, which tends to get very inefficient at high bit rates. So with that in place, we can now do encoding or decoding to or from raw formats and keep those in memory the same way we keep normal streams. We have some ways to do this. One of them is misproc mkvexec, which is literally the thing that lets you pipe a non-raw stream in Matroska format into a binary of your choice, and it expects the raw format out again in Matroska format, because you can actually send raw pixels over Matroska, in case people didn't know that. We also have a version that effectively uses the top one to call FFmpeg with the right parameters and do that. And then the last one, misproc-AV, is an integration with the FFmpeg library, so libav codec, and it does it more directly so that you don't have to send things over a pipe. That's the fastest one, but it requires compiling with the FFmpeg libraries, which makes distributions a little trickier. We also support just reading the raw pixels directly from a webcam with video for links. So now that we have a stream in raw format, we can do fun things with it. So we came up with a compositor process, which takes these raw video metadata buffers from shared memory, and will then read from them directly. And the neat thing is that if one of the streams then goes away, well, we simply make the pointer invalid, but we can keep rendering and not really care. If one of them falls behind, well, we just use the newest frame we have. If one of them goes ahead, well, we can theoretically go back a little bit, but at some point the ring buffer runs out and we'll get newer data than we wanted, but at least we'll have video. It will play something, so that's neat. The compositor receives configuration in JSON format from the control process, and then writes it to another pixel buffer, which we then can do the opposite to turn it back into something useful, like H.264, HEVC, AV1, whatever. And it lets us create cool little things like this, where you have multiple feeds in a grid, but they don't have to be in a grid. You can put them in any kind of free-form control, which is what the next slide should be about. Yeah. We also have a fancy web interface. I know it's a little small, sorry. There are bigger versions if you install the software. But there in the top, you can select what sources you want, assuming that they're in raw format, which this thing can do for you as well. You can pick if you want a grid, you want it freestyle, if you want like one of those old-fashioned security camera views, and then you can make it happen. As a neat little trick, we also added in support for, it's hard to see here, but we can actually put titles in the videos, so you can actually see what they're named or something like that. You can put your own text in there. We took a public domain IBM font to do that. And the neat thing is that if you change this configuration in the web interface or using JSON yourself with API calls, it updates in real time without anything going down. It immediately moves on to the next one. Which brings me to the next problem, that none of that is in sync. Like I said, it takes the last frame for everything. And well, everyone can take the last frame from everything, but it doesn't mean that they are synchronized to each other. If you have 2 cameras aimed at one thing, or 3 or 4 cameras, there will be a slight desync between them, because some cameras are faster, some cameras are slower. Maybe one of them is coming over the network and the others are not. Maybe one is going over a different media protocol than the others. And that's not fun. So how do you solve this? Does anyone have any ideas? No? Okay, well, this is the solution. This looks really stupid, and it is. This is a QR code that basically holds a UTC time in milliseconds. It's just the Unix time. Binary encoded so that it becomes as small a code as possible. You can change that frame rate. I mean, you can actually do this in real time. You can make this go faster. You can make it go slower. And each of these codes contains the time code. That clock on the top is just there for debugging. You don't actually need it. And what we did is that if the compositor detects in one of the feeds this code, it knows, when I see a frame with a code in it, that is the time that that frame should be displayed at, or is intended to be displayed at. It then looks at all the codes that we see in all of the feeds, takes the slowest of them, slows them all down to that pace, and boom, we're in sync. So what does that look like? Well, I pre-recorded a demo video. I would have loved to do it here in real time, but the setup alone would take 15 minutes, so that wasn't going to happen. So here is a little demo video that one of my colleagues recorded that is sitting there in the back. So this is MistServer's interface. For people that are familiar, it will look familiar. We're showing off here that we have, a camera feed that it is decoding to RAW, or I think that it's going to be set up to be decoding to RAW. Yeah, we're adding a decoder. And then the raw pixels are available for putting in the composer. So here we have a composer setup, currently with 3 feeds. And we're going to show off that all of them show the same thing, but from different angles, and that they're not in sync. He's going to clap in his hands, and you'll see that they're all not in sync at all. I mean, they're close, but they're not quite there. So then the next step is we're going to show that code on all the feeds. Yeah, he's quick showing off how that interface works. That's not really important. Not right now, anyway. So we're going to pull up the QR code generator, and we made that a progressive web app. So you can just load it on your phone and install it as like a little Android icon, and it will just pull up. It doesn't require internet because it's all local. So you show that to the feed, and you'll see that at the top there we put debugging info on. So at the top you can see some text. I hope it's readable. Probably not because it's tiny. But currently it says it is guessing the time based on the receive time. And as soon as I've managed to scan that code, which depending on your camera might take a while to get it not blurry. Everyone has experience scanning QR codes, right? But once it becomes not blurry, there we go. It has now synced it by QR code, so it knows what the time is. And you'll see that the clock that is running there is also synchronized to the clock that we see on the phone itself. And then we do that on all 3 of them. And once all 3 of them have the time code, then they'll hopefully be in sync. Well, I know they will be because it's pre-recorded. And you can already, if you are able to see this, it's hard to tell because there's nothing moving. Those 2 are already in sync with each other now, and the 3rd one will join them as soon as the code is scanned. Of course, you might not have the ability to get all your feeds in sync, and if you don't scan a code in any of the feeds, that one will just be latest frame, best effort. But now we have all of them, and now he's going to do the hand clap again, and we'll see that it is much more in sync. There we go, all synced up. And now for bonus points, we're going to add a webcam to the multi-viewer, which will in real time update it. And here you can see some of the interface as well, how you can position it like with a nice drag and drop thing. And you can just tell, yep, and then go back to the feed, and it will be right there. Normally it doesn't take that long to load, but it actually shut down because no one was watching it. And you'll see that the other 3 are still synced because they didn't forget their time codes. And now my colleague is realizing he forgot to put the debug info on that one, so he's going to turn the debug info on. There we go. And then once that is enabled, we can see it's also in sync. You can see it's already set sync by QR code. And now we're going to do one final hand clap with the fun fact that this webcam is terrible. You'll see the frame rate is absolute shit. It's terrible quality. And still, even though the frame rate is wildly different from the others, it is synced pretty well as we can do with that low frame rate. So yeah, that's the demo video. When can you use this? Right now, 2 days ago, we released 3.10 of MistServer, and it includes this feature. It's public domain code, so anyone can use it, anyone can steal it. You can reuse our sync code. We don't care. It'll work. Which brings me to the end, which is, are there any questions? Yeah, go ahead.
So you've shown us how you synchronize How do you deal with the clocks drifting after that?
That's a good question. The question is, we've shown how the clocks are synced, but how do you deal with drift afterwards? Right now, we don't. We found that in reality, most video sources tend to not drift that much. It will be like maybe a few seconds per day, which for most purposes, if you're doing a broadcast of an hour or two, you will not notice noticeable drift. If it does drift, you can simply show the QR code again and it will update its sync. Which is not ideal, but it works. So if you have like a particularly bad camera that tends to drift a lot, just show the code to it every 30 minutes or something and you'll stay in sync. Of course, you can also put it in the feed somewhere in a corner or something and then no one will notice, hopefully.
Yes, but the next time you sync it, you will have to be stalling some of the streams in order to synchronize the clock again.
So the follow-up question is, won't that stall some of the streams? Yes. What we actually do is we rewind all the other streams if necessary immediately. So you'll see some of them repeat a small section to go in sync. But it will keep going and the frame rate of the output does stay steady. So that's pretty nice. Anyone else? Yes, go ahead.
Have you thought of some pirates showing fake QR codes to actually delay the signal? Or so are the QR codes signed? Or
That's a good question. The question is, are the QR codes signed? The answer is no, not in this version. We did think of that, and the plan is to put a prefix in front of the code that you can determine yourself, and only if that prefix is visible then it would work. That's not a quite signing, of course. Yeah. The idea is that you would show these codes to the camera before the stream goes live, so other people don't see your prefix. And then theoretically, if someone is walking around with a sign with 1970 or something, then it will not ruin your life. Of course, we could add signing in the future. This is just V1, and if people say that this is going to be a problem, then yeah, we'll definitely add signing to it. And I bet that if this becomes a popular technique, we might have to. But yeah, we did think of that as well. Anyone else? Yes, go ahead.
Have you considered syncing by audio using something like LTC?
Yeah, we thought about syncing. Sorry, let me repeat the question. Have you considered syncing by audio? Yes, we thought about that. For now, we figured that video was the important thing to have in sync in this case. We want to add more audio support to the composer as well. Right now, we can copy an audio feed from one of the streams, but we can't, for example, mix them together yet. So if you have audio in two of them and you want to mix them, we can't do that yet. That's coming, but not quite. And at that point, I imagine it will become more important as well, especially if you have like audio-only streams that you want to keep in sync with the video. And we were thinking of putting some frequency signals in there that effectively do the same thing as the QR code, but then with audio. But if you have cool ideas, then share them. Anyone else? Yes, go ahead.
are the boundaries set on the time that you are allowed to sync?
What was that, sorry?
Are the boundaries set on the amount of time that you are allowed to sync? Because if you need to keep your videos in memory somehow.
Yeah. So is there a limit to how much desync you can have? Currently, we store, I think, from the top of my head, 200 frames for every raw feed. We figured that was a nice in-between of not having enough frames to sync within a reasonable time, and also not having so many that you run out of RAM all the time. That is configurable as a compile option. So you have to completely recompile the app if you want to change it, because that ring buffer was not made to be dynamically resized. 200 frames gives you, depending on your frame rate, a few seconds, which tends to be enough. But if you're really far behind, then you'll need more. What we're planning to maybe do is integrate the decoder more, because we could theoretically tell it, hey, when decoding, fall back this many seconds before you decode, and then the buffer can stay small, and we just slow down the decode a little bit. But we haven't had to do that yet. We haven't found cameras that are more than 3 or 4 seconds behind. So hopefully we don't need to do that, but maybe in the future. Yeah, go ahead.
Do you know if in the future it would be possible to detect if two cameras are out of sync somewhere?
That is a good question. I mean, we would be able to detect, of course, if we see the code again. But other than that, it would be pretty hard. So there are some ways that you can detect whether a camera is in sync or not. Like if there's a big change in the light, you may have noticed that when the guy clapped in his hands, we also turned the light on and off to make it more obvious where that point was. That works great, but you can't rely on that every time that the light changes intensity, that means you want to check sync, right? It could also be that Maybe a lamp was aimed at a camera at some point, but not at the other cameras. So that's not reliable. We would love to do something that checks this on the fly continuously, but we have not been able to come up with a reliable way. If you know one, let us know. All right, no more questions then? Cool. Well then, what was the end of the talk and the end of the Open Media Dev Room? I hope y'all had a good time.